Hi, I'm Dr. Jackie White from St. Leo University, and today we will be talking about ideas to keep in mind in experimental design and data collecting. If sample data are not collected in an appropriate way, the data may be so completely useless that no amount of statistical torturing can salvage them. So let's begin by reading some sources of data. Here we have some definitions that in an observational study, we observe and measure specific characteristics, but we don't attempt to modify the subjects that are being studied. Whereas in an experiment, we apply some treatment and then proceed to observe its effects on the subject. In an experiment, usually the group that receives the treatment is going to be compared with another one that does not receive any treatment. As an example, let's say the U.S. Food and Drug Administration randomly selects a sample of Bayer aspirin tablets. The amount of aspirin in each tablet is then measured for accuracy. That experiment describes an observational study because the FDA is observing the amount of aspirin but not applying any sort of treatment to any particular tablets. Let's look at different types of observational studies. In a cross-sectional study, data are observed, measured, and collected at one point in time. Whereas in a retrospective, or sometimes called a case control study, data are collected from the past by going back in time through examination of records, interviews, and so on. In a prospective or longitudinal or cohort study, data are collected in the future from groups sharing some common factors, and these groups are called cohorts. An example of a cross-sectional study would be TV ratings. Let's say the Nielsen Media Research Company surveys 5,000 households to determine the proportion of households tuned in to Saturday Night Live. They observe, measure, and collect these surveys all at one point in time. Let's take a look at some critically important issues to be considered when collecting sample data. One thing would be control effects of variables. Don't let other variables interfere with the effects you want to see. Another thing to think of is replication and sample size. You want to use a sample size that is large enough so that we can see the true nature of any effects, and obtain the sample using an appropriate method, such as one based on randomness. This then allows the study both to be valid because of the sample size, but also to be replicated in the future because you've documented or used a reliable way or appropriate method to collect the data. We also have randomization. What that means is to collect the individual sample items by using a random procedure that avoids bias. Otherwise, we might accidentally put some of our own bias in with the data, and that can affect the outcomes and make them unreliable. Let's talk in a bit more detail about randomization. In a random sample, members from the population are selected in such a way that each individual member has an equal chance of being selected. So there might be many ways to collect a random sample as long as the important thing is that each individual member has an equal chance of being selected. A simple random sample, on the other hand, is when you collect a sample of size n subjects, and that is selected in such a way that every possible sample of the same size n has the same chance of being chosen. So you're selecting a group of elements such that each group of that size has an equal chance of being selected. Or we have a probability sample, which involves selecting members from a population in such a way that each member has a known, but not necessarily the same, chance of being selected. So that's slightly different because each member might have a different chance of being selected, but you know ahead of time what the chance is for each of those members of being selected. We also have a random sample, simple random sample, probability sample example, as we just talked about those definitions. So let's picture a classroom with 60 students arranged in 6 rows of 10 students each. Assume that the professor selects a sample of 10 students by rolling a die and selecting the row corresponding to that particular outcome. So looking at this, then what we'd want to determine from those 60 students in the 6 rows with 10 students in each row is, would this give us a random sample, a simple random sample, or a probability sample? So remember, a random sample means every single person has an equal chance of being selected. Simple random sample means every group of a particular size has the same probability of being selected. Or we have a probability sample. So let's take a look. This would be a random sample because each individual student does have the same chance of being selected because it's 1 in 6. Since you're rolling a die, each row has a 1 out of 6 chance of being selected, and since each student is in exactly one row, they each have a 1/6 chance of being selected. But it's not a simple random sample. For example, the sampling design of using a die to select the row makes it impossible to select 10 students who are in different rows. So we cannot have different sets of 10, only the particular rows. The sample is a probability sample, though, because each student has a known chance, the chance of 1/6, of being selected. Let's look at some more types of sampling. We could have a systematic sampling, and in systematic sampling, we select some starting point, and from that starting point, we select every kth element in a population. For example, from the starting point, you might select every 50th element, and that would make up your sample. And there's always convenience sampling. Unfortunately, the outcomes are not usually as reliable with that, because what you just do is choose the sample that's the easiest to get, and that's why it's convenience sampling. We also could have stratified sampling. Stratified sampling is when we subdivide the population into at least 2 different subgroups, or strata. And then those strata share the same characteristics, such as gender or an age bracket. Then what we do is draw a sample from each of those subgroups, or stratum. So if we broke it into age brackets, we'd select a sample from each of the different age brackets, and that would be stratified sampling. Very similar is cluster sampling, because we also subdivide the population into sections or clusters. The difference is, in cluster sampling, we randomly select some of those clusters and choose all the members from those selected clusters. So rather than choosing a few from each cluster, we instead choose a couple clusters in their entirety for our sample. For example, the author of the textbook, he was an observer at a police sobriety checkpoint in which every 5th driver was stopped and interviewed. So that would be systematic sampling, where K equals 5, because every 5th driver was selected. Or a related example, an example related to drinking, would be motivated by a student who died from binge drinking. The College of Newport conducts a study of student drinking by randomly selecting 10 different classes and interviewing all of the students in each of those classes. That would be an example of cluster sampling, because what you've done is broken down into clusters of each group, since the population is broken into clusters by class. But then what they're doing is choosing 10 entire classes. So students in 10 randomly chosen classes are interviewed, and so that's cluster sampling. I'd like to conclude this lesson by mentioning 2 types of errors of which you need to be aware. The first type of error would be a sampling error. It's the difference between a sample result and the true population result. Such an error results from chance sample fluctuations. So again, that's an error that occurs in your sampling. But we could also have a non-sampling error, which occurs when the sample data are incorrectly collected, recorded, or analyzed, such as by selecting a biased sample right from the beginning, using a defective measure instrument, or copying the data incorrectly. So this is a non-sampling error because it's a mistake that was actually made in the process of sampling. So that was an actual error that was made versus something that was wrong with the data itself. This concludes our lesson on design of experiments. I hope you found it to be helpful, and I look forward to discussing more statistics topics with you soon.